Good afternoon everyone. Today my topic is evaluation of unreliable retrial GQ using Fuzzy ARAS method. Research overview. Research focus on single server retrial queuing system GQ, negative customer arrival cases in server breakdown, generative functions for steady state probability, unreliable server with random failure and reverse orbit return mechanism or blocked customers, batch position arrived with Bernoulli feedback. Key outcomes: performance and reliability measures computed, Fuzzy ARAS applied for multi-criteria ranking, unreliable retrial GQ ranked first, batch arrival retrial GQ ranked third, QI equals 0.975 achieved for the best model. Fuzzy TNF triangular fuzzy numbers handle logistic impression. Result validate unreliable server model. Introduction. Return GQ. Customers who find the server busy leave temporarily and retry after a random delay, common in telecom, network and manufacturing system. GQ, negative customers. Introducing by Jellyfin. Negative customers remove positive customers from service and cases server disruption, modeling and neural network. Unreliable server subject to random breakdown during service repair begins after a delay, models real world system failures in industrial application. And applications is network service, internet service, file transfer, mail service, cellular network, multiple processor systems. Fuzzy logics and triangular fuzzy numbers TNFs. What is a TNF? A style is equal to bracket 1 LMU, where L less than or equal to M less than or equal to U. L lower bound, M mostly like P, upper U upper bound. Why fuzzy logic? Real world criteria rating are impressive. Logistic systems, example, high, very good. TNFs capture this uncritically mathematically. Replace script number with fuzzy intervals. Enable decision making under ability. Alternative and criteria I will take now 3 alternatives and 4 criteria. A1 single server retrial GQ, A2 unreliable server retrial GQ, A3 batch arrival retrial GQ. Single server retrial GQ is basic retrial model with an on unreliability service work at all rate without reference model for comparison. Server next A2 unreliable retrial GQ. Server objective to random breakdown caused by negative arrivals repairs started after a delay, best overall performance. A3 batch arrival retrial GQ, positive customers arrive in batch under position process, adds batch complexity to retrial mechanism. Evaluation criteria: work vacations, random vacation, Bernoulli vacation, single vacation. Work vacation is server continues to serve customer at a reduced rate during vacation, offers a balance between rest and service, highest priority wait. Random vacation, servers take vacations at random intervals, vacation during in cottage medium weighted introduction significant unpredictability. vernally vacation. After each service, server either started vacation with probabilities or idle, very high weight, moderate, realistic, intermediate rest. Single vacation, server takes extraordinarily one vacation and returns to serve regardless of queue state, very high weight, clean and easy to analyze. Now Fuzzy ARAS method, 5-step process, consists fuzzy decision matrix, aggregated expert judgment into TNFS using geometric mean including optimal row AO, normalize each column, applied benefits or cost normalization formula so values are comparable across criteria, apply gradation weight, element is multiplied each TNF by its fuzzy gradation weight, W type J equal to LMU. Compute SI per alternative, some weighted normalized TNFs across all criteria, declassify using graded mean. Computed QI is equal to SI by S0 gives rank. Utility degree QI is equal to ratio of SI to optional SO. Highest QI wins rank. Fuzzy weight, criterion weight, terms, medium 3, 5, 7, high value 791, very high value 911, performance rating, logistic terms, fire 357, medium good 579, good 7 9 10, very good 9 10 10. Step 1, construct the fuzzy decision matrix xi ij, si ij is equal to lij, mij, uij, where lij minimum row value, mij r1, r2, r3 power of 1 by 3, uij maximum row of values. Criterion weight W type J, geometric means of TNFs, Lij equal to minimum values, Mij equal to M1 into M2, M3 power of 1 by 3, Uj is equal to max U values. Performance rating R tiles 1ij, row wise geometric mean, Lij equal to minimum row values, Mij equal to R1, R2, R3 power of 1 by 3, Uij equal to maximum row U values. I will calculate it before formulas. Criterion weight values, this table. Next. Step 2, normalization of the fuzzy decision matrix. Benefit criteria formulas, cost criteria formulas, non-benefit criteria formulas. Si ij normalization equal to xi j by sigma I si ij equal Lij by sigma uij, Mij by sigma Mij, uij by sigma Lij. Different demonstration for L and U components. Cost criteria, yes, xi ij normalization equal 1 by si ij equal to sigma ij 1 by xi ij. Fill TNF, then divide by column sum. All criteria C1 to C4 treated as benefit. Solve the example normalized matrix for C4. C4 single vacation. C4 normalization matrix table. I got A2 is the best values. Next. Weighted normalization B power ij equal to x tilde ij, but normalization into w tilde j equal to l ij into l wj, m ij into m wj, u ij into u wj. Weighted normalization matrix C1 work vacation calculation weighted normalization tables. Next, overall score of SI. Sum of weighted normalized values. SI equals sigma j v dash ij equal to sigma lij, sigma mij, sigma uij. Sum of overall J criteria. Sum of all weighted normalized matrix. All weighted C1, C2, C3, C4 weighted normalized table. I will say M2 is the highest values. Depreciation formula. Depreciation S tilde I equal to L plus 4M plus U by 6. Granted mean integration method convert TFN to single script value. Worked example A2 best SI M2 is equal to 1.350, 2.541, 4.293, 7.398, 10. D first is equal to 5.116. SI80 equal to 1.500, 2.707, 4.410, 7.612, 10. D5 is equal to 5246. Now QI value calculated. Step 5 utility degree QI and final ranking. QI is equal to Xi divided by X0, where 0 less than or equal to QI less than or equal to 1. Best alternative gives highest QI gives rank first. AI 0 optimal reference row QI is equal to 1 by definition. SI values 5.246. So QI value is 100. First A2 is equal to Unreliable Retrial GQ. QI is equal to 5.116 by 5.246 equal to 0.97 by. This is the best value in the analysis. Second one A3 batch arrival retrial GQ. QI is equal to 4.926 by 5.246 equal to 0.939. A1 is equal single server retrial GQ. QI is equal to 4.827 by 5.246 equal to 0.20. This visualization comparison comparison, QI value A unreliable retrial GQ is highest value, and next batch arrival retrial value, and next single server retrial values. SI value, QI values on the table, and I got ranking. First rank go to unreliable GQ, best overall the systems. Key finding and insights. A2, unreliable retrial GQ achieves QI is equal to 0.975, ranking first and close to the optimal batch marks. A0 equal to 100. Fuzzy DNFs effectively capture logistic imprecision in vacation policy rating provided by domain expert. C3 and C4 when only and single vacation carry the highest fuzzy irritation, weighted and structured vacation matter most. The Gantt mean integration method L plus 4m by 4m plus u by 6 reliably defalsifies the TNF sum into script score. QI values ranking only 0.920 to 0.975, reflecting that all three models are competitive, but A2 consulting outperformance, Fuzzy ARAS outperformance traditional MCDM top 6 etc. by handling ambiguous impressive to real world decision data. Why Fuzzy ARAS comparison with other MCDM method? Fuzzy ARAS handle logistic uncriticality via TNFs. Top is distance from ideal and anti-ideal. AHP pairwise comparison matrix. Utility ratio QI is intuitivity to interpret. Top 6 is well established literature. AHP is strong, consistently checks. Fuzzy ARAS single optional reference for AO. Top 6 does not negatively handle fuzzy input. AHP requires many compression at scale. Fuzzy ARAS computational effective 5-step process. Top 6 more complex distance calculation. AHP less suited by for fuzzy logistic data. Conclusion. The Fuzzy ARAS method effective ranked 3 GQ variant under and critically using logistic fuzzy weight, unreliable retrial GQ A2 achieved rank 1 with the highest utility degree. QI is equal to 0.975, best across a vacation criteria. Batch arrival retrial GQ A3 placed second, QI equal 0.939. Single server retrial GQ A1 placed lost with QI equal to 0.920. Fuzzy ARAS outperformance traditional MCDM methods by handling ambitious imprecise real-world data via triangular fuzzy numbers. Result validate the unreliable server model as the most robust option for system with vacation, breakdown and negative arrays. Thank you.